As I said, we had our probably warmest morning of the year this morning. It's already in the high 40s. And you'll notice that on the surface map, there's this cold front that stretches from Hudson Bay through Lake Superior, right through this western third, I guess, of our state, right draping across the central part of Iowa and then down toward eastern New Mexico. When this boundary makes its way through today, that's when the temperatures will start to drop a little bit, but it won't be excessive. But yet, the fact that this thing is still to our west early this morning is the reason why we're so exceptionally warm today. We're on the western side of a big anticyclone that gave us the clear skies, beautiful weather over the weekend. And remember, we're going to be starting to talk about why today in lecture about cyclones and the circulation around storms. But the circulation around a giant anticyclone region of high pressure is clockwise. And so all weekend long, as this thing continued to drift off to the east, we were in the southwesterly flow. These are the sea level isobars, and the flow, as we'll find out in the next couple of weeks, is more or less parallel to these isobars with high pressure to its right and low pressure to its left in the northern hemisphere. So the clockwise flow around the high gave us beautiful southwesterly winds all weekend long. Light though they were, they ensured warm advection, and that's what keeps us warm even this morning. There's a weak disturbance that's developing along the Carolina-Georgia coast, right in this inflection point in the coastline. That's an interesting storm that actually seems to have some sort of tropical-looking characteristics. We'll have to keep our eye on that as the week goes on. And then a more substantial event is getting organized over the southwestern plains, spreading rain over Kansas, Oklahoma, parts of Texas, even inching into Nebraska and Iowa. That's what will rain on us tomorrow, it looks like, and then snow again in eastern Colorado. So they had a big snow last weekend and then a relatively warm week and then some snow to start the week there again right now. And then unsettled weather across parts of southern Manitoba, southern Alberta, and British Columbia, and then Washington State, Oregon, and parts of northern California and Nevada. So a pretty interesting weather day. This is the first spring map we've looked at together, and it looks springy. It's not particularly stormy anywhere. And in fact, when we look at the temperatures here in a minute, you'll notice that it's not particularly cold anywhere. There's no place where it's really freezing cold. Maybe the high plains of the Dakotas in the teens near Pierre, but pretty warm everywhere else. And look at this little thin column of exceptional warmth that goes right up through the center of our state, including Madison, Green Bay, and then Houghton, Michigan, 49, 49, and 48 for that triumvirate of stations. And then a little bit warmer as you go to the south and west, but not really in a different category. 55 in Dallas is not entirely different from 48 in Madison. So just about the same kind of morning. The panhandle of Florida is quite warm, especially Miami at 60. So no place is baking in the warmth and no place is freezing in the cold as we wake up this morning. So pretty nice day across the country in terms of temperatures. And notice the warmth down in the southern states, you'll see, is also comes along with pretty high dew points. These dew points are in the mid-50s, high 50s, 58 at Victoria, Texas. And we only have a 30-degree dew point. So 48 temperature and 30-degree dew point, not very humid outside. So it's going to be a nice, comfortable day to begin with. But here's a little bit of a dew point spike right along where that cold front is. And that's because the circulation associated with the cold front drags water vapor a little bit along it. And so not uncommonly, one sees just a little bit of a spike there. And this might even be an artifact of the analysis that's done at the Weather Channel. I don't know. But it is not uncommon to have a little bit of a dew point spike as a front comes through. So we may see the dew point go up to the mid-30s, but you won't even notice the change. You'll notice more likely the change in temperature that comes on late this afternoon, evening, and tomorrow. But very warm, moist air to the south of us today. Okay. And then let's take a look at the satellite image across the continental 48 states and adjacent waters. Here's that collection of convective-looking elements that are getting themselves organized just off the South and North Carolina coast. And that's why I say it has a little bit of a tropical look to it. It doesn't really look entirely extratropical, that is outside the tropics. It has elements that make it look like it's a bit of a tropical generated storm. Now, that's not uncommon in the wintertime to see really heavy convection in these storms, but to see it cluster like this, just a little bit weird. We were looking at this on Friday in our weather discussion in the department and noting the same thing, and here it is coming to pass. So we'll keep our eye on that as the week goes on, or the next couple of days anyway. Here's a storm that's beginning to emerge, and that is take shape in the southwestern plain states. And I think in the first image of this movie, you'd say, boy, it just looks like a bunch of disconnected cloud elements. But by the last one, it does look a little bit more like a comma shape. It's clearly going to have some rotation associated with it at the end that's counterclockwise. So it starts to look like a more formidable weather system. And it looks to me as if this thing is just going to inch its way northeastward along this cold front that's making slow progress towards us. And so I think we will bear the brunt of this storm tomorrow during the day. And it could be moderate rain a couple of times during the day tomorrow. So it'll be one of those days, a rainy spring day. But that's actually what's needed. I guess we had a fire warning out over the state on the weekend. Probably should have been a little more differentiated than it was in terms of where was the fire risk really high. I don't think it was high in the southern part of the state. It might have been more in the northern part of the state. Quite a bit of that risk will be mediated by the incoming nature of this rain. And then one last thing, and we'll see a little bit more of this on the Pacific satellite image, is this cloud mass that's coming across the Pacific Northwest states, Washington, Oregon, and then into Idaho and Nevada. That's a system that's trying to get itself organized as it moves to the south and east. Okay, so a pretty benign weather system. Here's our radar across the country, a little more active than normal today. We've got some pretty decent looking shower activity in southern Nebraska, just to the southeast or southwest of Lincoln, and then some widespread, probably lightly convective showers across Kansas, also across Oklahoma and Texas, but nothing particularly scary. And that's good news for places that have recently dealt with tornadoes. And then here's some of the convective looking clouds off the coast of North Carolina. You can see a lot of yellow. That's pretty high reflectivity. And then speckled quite a bit with red and orange. And that means even more substantial convective activity, maybe hailstones falling out of that. This is occurring over really warm water. The Gulf Stream goes right up against the coast here in North Carolina. So, as I said, something maybe a little bit tropical going on there. And then some widely scattered showers, not only in the Puget Sound area, but then spreading to the south and east across Nevada, Oregon, Washington State, and Idaho and Northern California. So a pretty active day weather-wise in terms of the radar. And then here's the West Coast satellite image from this morning. Beautiful storm south of the Aleutian Islands. Look at that thing. I'll point out again with my cursor where the state of Hawaii is. For some reason, it's given a brown background. You can't really see it unless you look carefully. But there's where Hawaii is. So that's the boundary of the northern tropics. And this storm is well in the extratropics, outside the tropics. But it has flow entering into it very clearly from the subtropics in the northern hemisphere. And that's accounting for a good part of the cloud mass on its eastern side. But a really nice counterclockwise rotating cloud shield here south of the Aleutians. That might be the only one we can see on this particular satellite image. Here's the storm that's moving into the Pacific Northwest, and you can see that it's kind of sliding southeastward in flow that's broadly from the west-northwest across the eastern part of the Gulf of Alaska. So a fairly interesting looking storm in the central part of the Pacific, but not particularly well organized where the Pacific Ocean meets the North American continent. And then since we're going to begin talking about these weather systems in great detail today, I wanted to show you a mosaic across the whole globe of infrared satellite movie. And I'm going to have to page through this with my cursor so that you can see it. And so here it is from the 12th of March until this morning. And it's every 3 hours. I'm just going to page through. And you can see a couple of things the more you watch this movie. I'll point out some of the ones that catch my eye. And I'll do it at this slow speed to begin. First of all, at both the high latitudes in the northern hemisphere, that is above the equator, in both the northern hemisphere, or in this region, as well as in the southern hemisphere, south of the equator. So those are middle latitudes in the southern hemisphere. You'll notice weather systems moving from west to east with great regularity and with sort of an even spacing. Okay, so that's one thing. And those are the weather systems that we've been looking at in the satellite picture, naturally, because that's where we live, in the middle latitudes of the northern hemisphere. So we've been watching these curlicue type weather systems, comet cloud shaped weather systems, migrating across the continental United States and adjacent waters. They're doing the same thing across the low latitude Pacific and Atlantic Oceans on the coast of Antarctica. They rotate in a different way. They rotate clockwise in that hemisphere, if you watch. We'll have to explain that, and we will as we move forward in the next several weeks. And then the other thing that catches my eye is these tropical clusters of convective clouds, thunderstorms. They tend to move from east to west across the Congo in Africa, across the Amazon in South America, and then across the so-called maritime continent of Indonesia, Philippines, and other parts of the Southeast Asia. So that's really interesting. So we've got elements of a circulation of the whole global atmosphere that you can see by looking at these giant composites. And I'll go one more time slowly, and then we'll go through it at its regular speed, which is too fast. But once you've seen some of the elements, you might notice them again. west to east movement of the mid-latitude weather systems at both northern and southern southern hemisphere latitudes, and then east to west progression of the tropical disturbances near the equator. So here's the fast speed, which is a little too fast. But I think you can see those same things, propagation directions and everything else. You notice the darkness that comes across Saudi Arabia and Africa, at least at this image. That's just the heat of the day. So this is about noontime at local time for Saudi Arabia and the Horn of Africa, 9 UTC, 9 a.m. London time. So you're seeing that black strip is where the ground's heated up the most. So as it makes its way across the globe, you can see that. So there's some really interesting features of this thing, of this image that we're going to begin to talk about in our lectures starting today. Okay, how does this global circulation work? And we're going to focus first on mid-latitude weather systems. Okay.